So, hi, welcome back. This class has, this much stuff to go through before we take the NTC line. Okay? So far, we've only gone through about this much stuff. Okay? We got a lot more to do. So, we're picking up the pace. So much so that you're going to have a test this week Friday. Okay? So today's Wednesday, tomorrow's Thursday, you're going to have a test on Friday. Okay? It's going to cover 4-5, which was graphing tangents, graphing cotangents, graphing secants, graphing cosecants, and then I think that was it. Yeah. And then 4-7 is all of the inverses. Okay? And so all of that inverse stuff plus the stuff that we're going to talk about today, which is composition functions. Okay? So you will have two things due from everyone this week Friday. The first thing is you're going to have this wonderful yellow worksheet that all of your teachers in the first semester told you don't get rid of because it's going to be due second semester. Okay? So that one's going to be due on Friday. You will also get at the end of class today, you will also get the 4-5, 4-7 review packet, which will also be on yellow, which is also going to be due. Okay. Then we're looking at 5.1, which is trig identities, which is great stuff. And we will be testing on trig identities in 2 weeks' time, basically. Well, like 3 weeks from yesterday. We'll be testing on that. So we're picking up the pace. Okay? Because we got a lot of stuff that we got to get through in order to get through. Okay? The nice thing is we went slow on the foundation stuff to build that strong base, that strong foundation. Now we're going to take all that stuff. Okay? Let's do this. So what I would like to do is I would first like to start with, before we get into those, I would first like to start with a quick little review on the inverses. Okay? So our first one that we had, I think we did inverse sine. Of something, which was also the same as arc sine of something, which really, if you think about it, is the same as inverse cosecant or arc cosecant, right? Because cosecant goes with sine, and sine goes with cosecant. Yes? Okay. So when I'm looking at the unit circle to find the angles that those give us, where do I look for those four? Right side. Yep, I look at the right side. Oops. I have no idea what I just spelled out right there. I have no idea what the word SIND is. Okay? Which the output then is going to be somewhere between negative pi over 2 and positive pi over 2. Now, do we include those two in sine, or do we exclude those two in sine? Include? Okay. So if we're including them, then those are brackets. Okay. Then we moved on to inverse cosine. cosine, which is also really inverse secant or arcsecant. Where do we look for those on the unit circle? Somebody said. Top half. Okay. We're looking at top half. To stay consistent, I'm going to change this side to half. Which means we would be from 0 to pi. Inclusive or exclusive on those two? 50-50 shot, Rose. Are you in or are you out? You are in. You are correct. And then lastly, we went to inverse tangent. Or arctangent. Where are we looking for that one? Tangents. Other than looking on a beach. Tangents. Oh, that's the best my dad looks like. That's number one. Where are we looking? Top half, right half, left half, bottom half. No. I'm talking. Where are we looking? Look back in your notes. It should only be one page back because it should have been the last thing that we did. You actually even got a white packet about it. Where are we looking? Right half? Okay. So that's kind of like sine, right? Inclusive or exclusive on them? Exclusive? Yep, we keep them out because those are asymptotes. So we kick those out. Okay? With me? With that being said now, oops, I went too far. Evaluate those 6 trig functions for me. So if I've got the cosine of 1/2, I'm looking at the top half of the unit circle. I'm looking where the x value is 1/2. And it just so happens to happen at pi over 3. Okay. I'm going to go down the column. Sine, negative root 3 over 2. I'm looking right half of the unit circle. I want to find where my y value is negative root 3 over 2. That happens at 5 pi over 3. But because it's sine, I got to adjust it. And so I'm going to say that that is negative pi over 3. Tangent, root 3 over 3 is the same as the tangent if I unrationalize the denominator as 1 over the square root of 3. Looking right half of the unit circle. Where that happens is going to be when I've got sine, so y divided by x, 1/2 divided by square root of 3 over 2 gets me at pi over 6 for that one. Good so far on those 3. Okay. Cosecant, or the inverse cosecant, is really like the inverse sine of negative 1/2. Okay. Cosecant is a reciprocal, then I got to reciprocate that, and then all is well. That looks to be like a spam call. Ask me 856-225-0533. Okay. So look at right side where it's negative 1/2. Want to say 11 pi over 6. However, we're going to say negative pi over 6. Good so far. 4 for 4. Yeah. Okay. Secant is like cosine. The reciprocal of 1 is 1. So I'm looking for where top half, where cosine is equal to 1. That happens at 0. Cosecant, negative root 2. Well, that again is inverse sine of 1 over, or negative 1 over the square root of 2, which if I rationalize that denominator, then that would become negative square root 2 over 2. And so I'm looking right side where that's negative root 2 over 2. That happens at, I want to say 7 pi over 4, but to make it fit, I'm going to say negative pi over 4. 6 for 6? Nailed it. Love it. All right, let's talk some composition of functions. So the fancy way of saying it is composition of function. Ooh, they left me a 21-second voice. Might not have been a spam call. Yep. You take a value. In this case, in the first case, it's 5. You take that value. We're going to plug that value into the function machine that is g. So I'm going to plug that function into g. I'm going to get out a value. I'm going to put it into that function machine, and out pops an outcome. Whatever the value of 5 is in g. Then I'm going to take that value, and I'm going to plug it into f. You're working inside out. Okay? So the first thing that you're going to do is you're going to find g of 5. Well, that's going to be 5 squared plus 7, which is going to be 25 plus 7, which is going to be 32. Then I need to take f of that. So I'm going to take f of 32. That's the value that I got when I did the inside one. Now I'm going to put 32 into my f function. Two times 32 is 64, plus 3 is 67. So f of g of 5 is 67. Okay? You find me now f of the inverse of f of 10. Cool. I get f, whoa, maybe I don't. Now I do. F of the inverse of f of 10 is 10. Would you concur? Does that make sense? If they truly are inverses, then they should cancel each other out. Yeah? Yeah? Love it. how this works is we're going to be on the unit circle and we're going to be evaluating composition of functions, and we're always going to be giving our answers in radians. Okay? So same process. First thing that you're going to do is you're going to figure out first the arc cosine of 1/2. Top half unit circle, where is cosine 1/2? Happens at pi over 3. So this is pi over 3. Then you're going to find the sine of that angle. So you're going to find the sine of pi over 3. Looking at pi over 3, the sine is square root 3 over 2. So the sine of the arc cosine, forgot the C again, forgot the C in the last class, same problem, of 1/2 is the square root 3 over 2. Yes? Yeah. You find me the cosine of the inverse sine of negative square root 3 over 2. Negative pi over 3. Cosine down there is also 1/2. So the cosine of the sine, inverse sine, of negative root 3 over 2 would be 1/2. Agree? Love it. Let's switch spots with those. So meaning, let's put the regular trig function inside and the arc trig function or the inverse trig function on the outside. Okay? So we have something along the lines of inverse sine of the sine of pi over 3. Now, normally, if we were back, we just did the f of the inverse of f of 10, and I said normally an inverse cancels out that regular function. Okay? In trig, we got to be careful with that because, especially when we're dealing with sines and tangents, because if we get down here in a quadrant 4 angle, then we've got to make it be a negative angle. Okay? So, got to be careful with quadrant 4 angles when they're in this order. But the way you go about doing it is still the same. So first off, you'd figure out what the sine of pi over 3 is. And the sine of pi over 3 is the square root of 3 over 2. So then, you take the inverse sine of the square root of 3 over 2. Right half, unit circle. Where is sine positive root 3 over 2? Well, that happens at pi over 3. So the inverse sine of the sine of pi over 3 is pi over 3. Because that wasn't a quadrant 4 angle. We're good there. Okay. Now, here in number 4, now I'm dealing with a quadrant 4 angle. Okay, so we'll see how that adjusts it a little bit here. So we first take the sine of 5 pi over 3? Well, negative root 3 over 2. Then, we take the inverse side of that. Now, because it's right half of the unit circle, and I'm in quadrant 4, it's not 5 pi over 3. It ends up being negative pi over 2. Okay? Let's take a trip off of the unit circle now, sticking still with trig identity or trig functions. Okay? So now we're going to be off the unit circle. So the first thing that we need to do is we still want to take the arc cosine of 4/5. But that's just going to give us some angle. And we'll call it theta. Well, let's figure out where that is. Arc cosine is top half of the unit circle, right? Where is arc cosine positive? Quadrant 1 or quadrant 2? Quadrant 1. So let's draw ourselves a quadrant 1 triangle. If I draw myself a quadrant 1 triangle, then this angle here is going to be my theta. And the arc cosine would be, for that angle, would have an adjacent side of 4 and a hypotenuse of 5. How can I figure out the missing side? What do you got? Pythagorean theorem, or it's just 3 because it's a Pythagorean triple. Yep. So this side over here is going to be 3. If you don't know that, we could have done 5 squared equals 4 squared plus b squared, 25, 16, b squared, 9, b squared, 3 is b. Because we're in quadrant 1. You don't have to worry about the negative. Okay? So then, now, what you're going to do is now you're going to take the sine of that theta. Well, so here's my theta now. What's the sine of theta? So Katoa tells me it's, Mad Dog, 3 over 5. So the sine of the arc cosine of 4/5 is 3/5. Okay? You find me the tangent of the arc cosine of negative 8/17. Which quadrant do I want to be in? What? Quadrant 2 angle? Or triangle, I should say. We're just going to make my theta be there. still adjacent over hypotenuse. Pythagorean theorem says the 289? Yeah. $15 for B, or for your missing side. Okay. So the arc cosine of negative 8/17 is going to give me theta. The tangent then of theta is going to be the opposite, which would be 15 over the adjacent, which would be negative 8. So the tangent of the arc cosine of negative 8/17 is negative 15 eighths. Agree? Now, let's get real funky. Let's give an algebraic triangle. Roll your eyes and be there, sister friend. Okay? Nice part about an algebraic triangle is you're going to set them all up in quadrant 1. Okay? And then you're going to let x determine if it's positive or negative from there. Okay? So if I set this triangle up in quadrant number 1, here's my theta. So I would be looking at here at arc cosine of 3x over 1 as my theta. Agree with that? Can I write that like that? And write 3x is 3x over 1. That allows me then to come back to my triangle and say, well, my adjacent side is 3x, and my hypotenuse is 1. Now we got to do a little Pythagorean theorem. We can't get by without it. 1 squared equals the quantity 3x squared plus b squared. I want to solve that for b. So I have 1 squared is 1. 3x quantity squared is 9x squared. Subtracting 9x squared, that'd be 1 minus 9x squared is b squared. And then I take the square root and I get that. So this missing side here is the square root of 1 minus 9x squared. And now I can find the sine of that angle. So the sine in that triangle is going to be the opposite side over the hypotenuse, or simply just the square root of 1 minus 9x squared. Questions, comments, concerns, clarifications? In answer to the question that you're thinking, doesn't that radical simplify because 1's a perfect square and 9x squared is a perfect square? And the answer to that is no, because the square root That is Hall of Fame bad maths. Right there. Okay? So we've got to leave it as that. Alright? You now figure out for me the cosine of the arc sine of 2x. Cosine is adjacent over hypotenuse. So the cosine of the arc sine of 2x is square root of 1 minus 4x squared. Yes? Well, two more. Try those two. The nice thing about both of these triangles is you only have to do one Pythagorean theorem. You just have to change the position of it for the second. So secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. So here in the first one, the secant of the arc cosine of x is 1 over x. In the second one, tangent is opposite over adjacent. And even though, now I'm going to say this and some of you are going to say, oh yeah, they are. Even though these are on the unit circle, we are not requiring you to rationalize the denominator. We're okay with the algebraic ones being non-rational. Did you know that the algebraic fractions are on the unit circle? Or the algebraic triangles, I should say. Because what's the radius of the unit circle? 1. And the radius on the triangle is the, which part of the triangle? The hypotenuse. And all of these hypotenuses are 1. All of them are on the unit circle. But we're not requiring you to rationalize. Okay? I'm going to hand out the review assignment for this unit in preparation for your test on Friday.